Okay, so the number of mole of nitric acid would be 5 mole. Okay, number of mole of nitric acid is 5 mole. You have to find out how many moles of magnesium carbonate that will react with 5 mole of nitric acid. So same thing, you look at the mole ratio. Mole ratio of what? Mole ratio of magnesium carbonate and nitric acid. So from the first row of the mole ratio is always from the balanced chemical equation, which is here. What is the mole ratio between magnesium carbonate and nitric acid? 1 mole is to 2 mole. So 1 mole, 2 mole. Second row of mole ratio from what is given in the question. So now you have 5 mole of nitric acid. So 5 mole. So this one would be 2.5 mole. Okay, so the answer is number of mole of magnesium carbonate, there will be 2.5 mole. The last part of this question, another nitric acid solution is made by diluting 1 mole to make 2 dm cube of the solution. What is the concentration of this solution in mole per dm cube? Mole per dm cube, mole over dm cube. So just take the ratio. So the concentration, 1 mole, 2 dm cube. Okay, that will give you 0.5 mole per dm cube. So this question is very easy, just take the ratio. Okay, again this is 2013, paper 3A5. Now you're not going to learn anything if you just watch this video, you have to do it. So my advice is, after you have learned how to do it, after that, what you need to do is look at the question, don't look at the solution, and do it on your own. And then after that, check the answer. Check whether or not you get the final answer correctly. Now the next question is section B. It's an essay type question from 2006 O-level combined chemistry, paper 3, B10. First question, 1A, define relative molecular mass. Okay, so this is straight out from the textbook, the definition of MR. So MR is the mass of an average, is the average mass of a molecule of an element or compound compared with the mass of compared with 1/12 of the mass of a carbon-12 atom. Okay, so you can actually refer to the textbook and get this definition of relative molecular mass. (1B), nitrogen N2 and hydrogen H2 are combined together in the industry on a large scale to form ammonia, NH3. Okay, write the balanced chemical equation for this reaction. Include state symbol. So 1B, part 1. So you have N2, you have H2, and then that would give you NH3. So your next step would be to balance the chemical equation. You have 2N on the left hand side, on the right hand side you have 1N, so put a 2. So the N would be balanced already, but how about the H? There are 3 H's, 3 times 2, 6. Over here, only 2, so you put a 3. And then you have to write the state symbol. Ammonia is a gas, hydrogen is also a gas, nitrogen is also a gas. So this is the answer. Calculate the relative molecular mass of ammonia. Relative molecular mass is MR. Now remember, when you calculate the MR, you should not calculate the MR for 2NH3. This 2 is just to balance the chemical equation. or it can means it can mean 2 mole. When you write AR, when you find AR, you should only find AR for the chemical formula without the number in front, because the number in front is not part of the chemical formula of the substance. So MR for NH3, 14 plus 3, that would give you 17. Remember, MR, AR, there is no unit. Part 3. What volume of ammonia measured at room temperature and pressure may be formed from 6 dm cube of nitrogen? So you have 6 dm cube of nitrogen, 6 dm cube. What would be the volume of ammonia formed, measured at room temperature and pressure? So this is N2 and NH3. So you have to look at the mole ratio. Mole ratio of N2 and NH3. Not 2 NH3. Is NH3. What would be the mole ratio? 1 mole is to 2 mole. 1 mole, 2 mole. Then after that, the question say 6 dm cube. So 1 mole, 2 mole. 6 dm cube. This is how many? Now, for a chemical equation that involves gases, you have to always remember mole ratio equals to volume ratio. Okay, so there is this thing called mole ratio equals to volume ratio. Now remember, this volume is the volume of gas, not volume of liquid. Mole ratio equals to volume ratio. As long as the substances that you are looking at, they are in gaseous state. In this case, N2, NH3, they are in gaseous state. So you can apply this concept. Mole ratio equals to volume ratio. It means that if the mole ratio is 1:2, the volume ratio should also be 1:2. So 6 mole, so this one would be 1:2, 6 would be to 12 dm cube. Okay, so in this case, the volume, so therefore, volume of NH3 is 12 dm cube. Okay, volume of NH3, 12 dm cube. Mole ratio equals to volume ratio. 1:2, 6:12. Next question, calculate the mass of this volume of ammonia. So this 12 dm cube of ammonia is how much the mass is. So how do you change from volume to mass? Volume to mass. The volume and mass, actually there is no direct relationship. But from the volume you can change it to mole. 1 mole of any gas occupies volume of 24 dm cube. Okay, so mass of 12 dm cube would be 1 mole, 24 dm cube. 12 dm cube would be 12 over 24, which is 0.5 mole. And then from the, sorry, not mass of, it is actually number of mole of 12 dm cube. So 12 dm cube is 0.5 mole. Then what would be the mass of 0.5 mole? So mass would be mole times the mR, 0.5 times the mR of ammonia, which you found it in part 2 already, 17. And that would give you 8.5. 8.50 gram 3SF. Okay, so volume and mass, no direct relationship. You have to change the volume to the number of mole first, and then from the number of mole change it to mass. Okay, for number 2, this question is from 2008 paper 3 B10B. Calculate the mass of sodium carbonate contained in 250 cm cube of a solution of sodium carbonate with concentration of 2 mole per dm cube. Now again, you can change 250 cm cube to dm cube. So number 2, 250 cm cube is 250 divided by 1000, which is 0.25 dm cube. You can look at it, 0.25 dm cube and then 2 mole per dm cube. If you multiply these two numbers, what do you get? Look at the unit. If you multiply dm cube and mole per dm cube, the dm cube would cancel off. Okay, so if you multiply dm cube and mole per dm cube, the dm cube will cancel off to give you mole, which means that if you multiply these two numbers, the value that you get is the number of mole of sodium carbonate. Okay, so number of mole of sodium carbonate is 0.25 dm cube times 2 mole per dm cube. 2 mole per dm cube. So the dm cube will cancel off to give you 0.5 mole. The questions 1, mass. You got the mole ready. Can you find mass? Yes, of course. But before that, you need to find what is the MR. MR of sodium carbonate. Sodium carbonate is Na2CO3. What would be the MR? 23 times 2 plus 12 plus 16 times 3. So if you do this, you get 106. MR is 106. And what would be the mass? The mass is the number of mole, which is 0.5, times the MR, which is 106, and that would give you 53.0 gram in 3SF. Okay, so this is actually a two-step problem. First of all, by recognizing that mole per dm cube and dm cube multiply together, you can get the number of mole, which I did it here, number of mole 0.5 mole. And then from the number of mole, you can find the mass as required by the question by multiplying the number of mole and the MR. Alright, again, by just watching this video, you are not going to get better until you really do it. So my advice is, after watching this video, you look at the question and do it, and then after that check your answer, see whether you can get the final answer correct. Now you don't need to have this book. You can just look at the question in this video and then do it. Okay, with that, this is the video for O-Level Combined Science 10-year series question. Thank you for watching. Bye bye.